Welcome, everyone, to another episode of New Breakpoint. We are starting our new season with an old favourite, that is Graeme Foster. So I am super pleased to be welcoming him back. For those of you that are new to the series, New Breakpoint is a show for developers by developers, and we broadcast on the second Thursday of every month. Graeme and I will be online during this episode answering your questions, so feel free to put questions into the chat at any time. Okay, so welcome to the show, Graeme Foster.
Hey,
Great.
Michelle.
For those who haven't seen our previous seasons, why don't you introduce yourself, a little bit about who you are and what you do?
Thanks, Michelle, and great to be back again, as I'm saying more and more often now, actually. So thanks for having me back. Hey everyone, my name's Graham. So I work for Microsoft as a technical specialist. Maybe a different role by the time this goes out, but we'll see. And I specialize in applications on Azure. So that's traditional applications that are using services like App Service and AKS. But now, of course, we're in the new world where there's so much interest in large language models and AI applications. So I do a lot of work in that space. So I've been on New Breakpoint now a few times. Feels like years back now when I did my first one, which was on Azure Active Directory at the time. But we've done a series of LLM ones since then, which I think is kind of nice because they all actually, in some way, lead up to this one. It's quite nice. There's just been this progression. We've been following LLMs and AI applications and what people are doing with them. And each time we've done a recording, it's the thing that's kind of new at the time, but they're all sort of building up to this one today, which I think is a really, really interesting and good one.
Oh, well, maybe we should just mention what the previous ones were so people can catch the whole series. So,
Yeah,
the previous one that you did last season was like Rag Plus. What was that called?
Graph Rag. So we
Graph
did a
Rag.
series where we looked at the traditional approaches to RAG, and we talked about where they were really good and where also they were maybe not as good as some of the more modern approaches. So we did a session on a technique called Graph Rag, which was all about using knowledge graphs to be able to ask very interesting kind of meta questions of your data. So GraphRag's kind of got quite a lot of traction now. So it's really, I think, it was a good grounding, and hopefully people got a lot from that session.
Yeah, cool. But they should still, even if they watch that one, they should
Mm.
still watch the one before that,
The one
which gives
before.
the original story about what a rag is
Mm.
and how that works and why you might use it, because that starts you right at the beginning and gives
Yep.
you a good place to understand everything from, and it's still
Yep.
relevant. And then to
Absolutely. And
graph
you
rag,
know,
and then where we are today.
yeah, and that one was really interesting because that one, the very first one we did, it focused on what are large language models actually doing and how are we building applications from them. And actually looking back on that one, what was quite interesting is that there's been a bit of a pivot. Like that one was based off kind of, if you like, V1 of large language model applications, where we were sending little prompts to the LLMs and then we were using workflows in code. So those of you that have worked with LangChain or have done stuff with semantic kernel will be aware of this idea, or even prompt flow, where you send the prompt to a large language model, you get the response back, you look at it, and then you send a completely different prompt to the large language model, and so on and so on and so on until you have the answer to send back to the customer. And I think what we've seen certainly over the last year is everyone's now talking about agents and agency. And it's a kind of paradigm shift from those initial LLM applications. And it's what we're going to be looking at today is kind of agents and how agents communicate.
Oh, fantastic. So we were just at Agent Con last week. And in Agent Con, everyone, well, the whole town was introduced to the idea is what is an agent? What is MCP?
Yeah.
What might you use agents for? What are the good scenarios and all of that? What are we going to be talking about in today's episode?
Yeah, literally most of those things apart from the MCP bit. So MCP is a big topic on its own right, and I'm sure someone's going to do an MCP talk in this series of new Breakpoint. So what we're going to focus on today is that initial question of what is an agent? We won't spend too long on that one. And then we'll have a quick look at some of the ways, certainly on the Microsoft stack, that we can work on what we call multi-agent architectures today. But then we're going to really dive into a protocol that was put forward by Google a few months ago. It's actually, Microsoft have now got involved. It was donated to the Linux Foundation just yesterday or the day before, which is also pretty exciting. And it's trying to answer this question of, we understand agents and we understand how agents can communicate in a kind of walled environment where they can see each other really easily and they can share messages with each other. But what does that look like on the internet, right? So we're now talking about not just agents in your company, but you're a company A, company B's got agents. Like, how are they going to talk to each other? They may be built on different stacks. They may be built in different languages. And what we don't want to end up in is a world like we were many years ago with APIs, where your API couldn't talk to my API because we just couldn't agree on protocol.
Or worse, where the agents are all running around unfettered with ungoverned access to everything, and they're just I don't know, off trading stocks with my money without me knowing about it.
Right. Yeah. So we'll have a talk about security between the agents and how they can ask of things of the users who may not even be users. I think that's one of the really interesting things we'll get into is, the consumer of your agent may not be a person anymore. It might be an agent. Like, what does that mean now when it comes to asking permissions of a user that might be 3 agents away from you, who might not necessarily be aware that that agent is about to try and execute a transaction on that user? It's, I don't know. Yeah. There's so many interesting questions around this area.
Because when we were first putting out chatbots, one of the key principles around transparency was that the chatbot should be open about the fact that they are a bot, they are not a human being, and that there should be a possibility to hand off to a human being if that's what was wanted. But as you say, in this case, there can be multiple steps that are going on in the background because everything's happening so fast, and each of those agents is so proficient in their particular skill that there isn't time to be checking with the human in the loop at every stage. A lot.
And the more you think about it, the more it's like, wow, there is some, and I'll be really honest here, I don't necessarily think that there are solid answers to a lot of these problems yet. And this is what makes this space so exciting, but also quite scary at the same time. So you could ask, you could put an opinion forward on how that kind of delegated authorization works in the agent world. And you might see that Microsoft are pitching a concept of Entra agents where they want to get changes to the fundamental specifications behind OIDC and OAuth to introduce the concept of an agent, whereas Auth0 are looking at a different approach to this, using some parts of the OIDC, I can't remember exactly what it was, but ways that a downstream API can request something of a user over here using kind of back channels and SMS and things like that. So it's one of those really interesting discussion spaces that's still very lively and undecided.
But are they? Is everyone agreed at least that agents should have identity? And yeah,
I think so. I think there's a general consensus that yes, agents should have identity, and actually, I mean, like, this is really interesting. Right before we even get into the demos and things, one of the things, there's a really interesting community post from somebody who works on Entra, talking about concepts like, well, an agent is it's not like a traditional API. So with a traditional API, we might give it, let's say you're in the Entra world, you might give it access to read all of SharePoint so it can act as a daemon style application on behalf of whoever's using it. But there's this kind of fundamental change when we think about agents, that they're more they're more like a real user than they are like a traditional background application. So
Mhm.
maybe they need their own OneDrive, right? Maybe they need to be on access control lists to documents so that we can get very particular about what they can do and what they can't do. So I think it is this kind of middle ground of not a user, but maybe an agent should have to PIM up if it wants to access a sensitive document and
Yeah.
actually get permission from a real user to do that.
Well, definitely that. The same just-in-time methodology that our own engineers have when they're accessing customer
Mm,
data, for example. I think
exactly.
it needs to be something like that because of the transparency, the traceability. We want to be able to say if something went wrong, where did it go wrong, and who did
Hmm.
that? And when I say who, which agent
Yeah.
or which person, it doesn't, as you need to be able to pinpoint that so that you can iterate on that and fix it if it was an issue.
Yeah, exactly, exactly. And it gets super interesting when you cross organizational boundaries as well. So you might not be talking to an agent that has got an identity in Enter, it might have an identity somewhere else. So
Mm,
it's a really interesting space. And it's one where the specification for A to A says a few things about authorization, but it's quite it's quite open on certain aspects of it. So what I've spotted over the last couple of months since agent to agent the protocol was announced is that we've already gone through like two or three iterations now where one in particular had quite significant changes to the underlying base methods and specifications, such that a lot of the demonstrations all broke. Like I was watching one of our build demonstrations on A to A, and the guy doing it made a point of just saying like, this really doesn't work now because the protocol changed 2 days ago and we didn't know it was changing. So what we're
mm.
showing you is now completely out of date. So I think we'll see over the next few months. I do wonder if some of these questions around authorization and authentication will be addressed, and more kind of solid techniques will start to appear, or whether it will still be left to the side. It's interesting.
I think so. I've always been super interested in responsible AI. And when I was
Mm.
first into it, it was very much a philosophical topic, which I enjoy because I have a background in philosophy. But
Okay.
but there wasn't much that was operationalized. It was all very manual. If you needed to implement it, you needed to write a policy and you needed to get your people to follow that policy.
Mhm.
Over the past couple of years, it, Microsoft and I presume everyone else has operationalized a lot of those processes, and so you can just turn things on, you can tick boxes, you can enable stuff to prevent jailbreaking, to prevent prompt
Mm.
injection attacks, to control the level of naughtiness in language from, you know,
Yeah.
not no swear words at all for primary schools to anything you want to say to for emergency services, that
Yeah.
kind of range as well. But I did a talk at AgentCon last week on trustworthy agents, and our colleague George, who is in security, said,
Mhm.
Michelle, that was a security talk that you did there. And
Oh man.
and
Yeah.
and I hadn't realized, that we were getting closer and well, the AI was getting more and more integrated with what was a separate field entirely.
Mm.
Um, because yeah, to me, all of that stuff made sense. It's just the next level. It's just the next thing
Yeah.
that you need to be sure is locked in there. And so yeah, now apparently I know about security. So
There you go. Everything is coming together. And I have to say, like your comment on philosophy there took me back for a moment to my 9 a.m. Friday philosophy lectures when I was at university as well. I had a flashback. I'm not sure if that was a good thing or bad thing to hours spent listening about perceptual consciousness and things like that.
I'm losing a little faith in your university because no university really runs a philosophy lecture at 9 a.m. we,
So
we
true.
were all up in the union discussing philosophy till 2 a.m. We can't be up for a 9 a.m. lecture.
I think I was dancing at the indie disco until 2 a.m. on Thursday night. That's why philosophy at 9 a.m. was so hard. But it's actually, I mean, it personally is quite interesting because my degree was cognitive science, so it was all around the second AI wave of neural networks and perceptrons and the philosophical implications of like creating these things that looked and mimicked the way that human brains worked. And then that died off for so many years. And a lot of my friends who were stayed working in the field drifted into more kind of, it seemed to go down a more statistical, mathematical pathway into like Bayesian probability networks and things that I didn't really understand. So it's fascinating now that everything is, well, maybe not everything, but it's come so full circle back to the idea of neural networks being the primary driver. And I was laughing with a friend of mine who's a professor at Brunel now the other day, just saying like how ironic that we're both now seem to be working. I'm in the application of these things, whereas he's in the kind of like, what are the implications of these things? But we've sort of come full circle on that, which was interesting.
Yeah, it's great that those conversations are closely linked again, because that
Yeah.
is, well, really at the heart, I think, of who we are as humans and how we
Mm.
interact with the world around us.
Yeah, definitely, definitely. I mean, sorry, I know we're kind of nattering on here, and we haven't got into A to A yet. But it was interesting. I remember seeing the Apple paper the other week around the reasoning, and these models aren't reasoning. And I sat back and I was like, well, it's interesting, but what does it actually mean to reason? This is my philosophy background
Yeah,
coming back. I
yeah,
think like we don't have like defined circuits that are like workflows in our brain. We have neurons that light up. So
mm,
maybe part of those neurons is just a scratch pad, which is remembering what's going on and being able to go back and reason over it. And
yeah.
how different is that to what the reasoning models do?
That's exactly what I think as well. I understand why they don't want us to humanize the AI,
Totally.
but also I think it's a little bit unfair to
Mm,
say that we can only define things like consciousness in human terms. That, that we couldn't say that trees have a consciousness
mm,
or whatever, when they clearly do have ways of communicating, and they're just not like us. And so
yes.
in the same way, I think just because things were artificially created, it doesn't
Mhm.
mean that they don't have a validity the same as we do.
Right.
So, and also I think probably part of how I do stuff in life is I try and translate technical things into human terms. So it is
Right.
difficult for me to anyway say that they're not the same, keep them apart, because, people understand things when you put them in their terms. But anyway,
Absolutely.
enough
But
of
one
this.
last thing, one
Yeah.
last thing, I want to leave that with a thought experiment. And I remember we did this in philosophy, and the thought experiment was like, if you take a human brain, right, it's billions of neurons or hundreds of millions, whatever, and you replace one with an electrical component like a transistor that does exactly the same thing as that neuron did. And the experiment was, is that consciousness, that person still the same? What if we replace two? What if we replace three? And then the question was, at what point does that consciousness stop being the same consciousness? Now it's being replaced with transistors that look, feel, and act the same as each of those neurons. And that was the thought experiment. I remember quite vividly from those nine. One of the things I do remember from those 9 a.m. philosophy lectures. All right.
Yeah. Great.
Awesome. Cool. So we're not here to talk about that. Anyway, we're here to talk about agents and agent to agent protocols. So I got a few slides. I've got some demos as well that we can look at to try and sort of work through this, what it is, how it works, etc., etc. So what I think I will do, if it's all good, is I'm going to share my screen. So let's see how I'm going to do this. I think I'll just share the screen. Then I can easily move things on and off in different applications. So I'm not going to flick through the slides properly, but we're here today to talk about agents to agents. And let's start with this like defining question of what do we mean when we talk about an agent? Alrighty, so we're here today. We're going to talk about agent-to-agent protocol. So before we get into it, though, let's just start. I think this is one of those questions. Everyone's saying the word agents. I saw a funny video just last week at AgentCon at the start where we literally had so many senior people in technology giving a different definition of what an agent was to them. So I don't know about you, Michelle. I've got this little summary here that I think is quite nice. I think I got this from a Google page actually. But it starts off by just defining an agent pretty simply as something that will pursue a goal on behalf of I think this said user on the actual one, but I've turned it into consumer because I don't think the agents will always be used by real people. But that goal may happen quickly, but it might also take some time as well to happen. So what do you think of that one?
Yeah, yeah, that seems fair.
That seems fair. All right, cool. So moving on, I think also agents are using tools and resources and prompts. So this is where the MCP thing comes in. So model context protocol is all around making it easy for models, multimedia models, large language models to interact with their outside world. And I think that's a key component of an agent as well, because it needs to look at and manipulate the environment around it to be able to help achieve those goals. So that might be calling an API to look up, say, flight times. It might be reading some document from somewhere. But to help achieve that goal, this agent is going to have to use what's available to it to do that.
Yeah, I think, that really, I didn't really understand what was the difference between agents and for example, like a Copilot chat thing until I saw that happening in action, where Copilot chat would tell me the series of steps I needed to do, and I would then need to manually type those in or copy paste those in. When it's an agent doing it, it says, this is what we're going to do, and then it does it. And you just have to hit continue or okay if you agree with that, which, magic.
I think the first time I really got a feel for that was when I was using GitHub Copilot in agent mode. And it sort of said, oh, I'm going to go and create, I think it was a React Native project. I'm going to create a new React Native project. Sure. Yes. And then suddenly my terminal started being automated as the commands went in for npx to do that. And then it sucked the output back in and then carried on. It was like, now I kind of get it. Like when we talk about interacting with the environment. So that was really interesting.
But I like that it explains to you what it's doing as it goes along. So you're not left feeling like it's totally taken all control away from you. It's explaining stuff. And if you don't agree, you can back that out. You can say,
absolutely,
no, undo that.
Yeah. I wonder, I'm not quite sure how close we are to this kind of world where we really let these agents go off and start to mutate data. I think, calling APIs is one thing, but as we start to interact with other resources, having that human in the loop, I think even for an agent flow is still often something that maybe not for all of the API calls, but for some of them, we're probably still going to want that.
Well, I'm on an advisory board for a lot of universities and TAFEs, and I've been saying to them recently that I think should be the first lesson of the school year, teaching them how to work with these AI agents as co-pilots, as opposed to just giving it over all control to it and, just sitting back and letting it do your job for you. Because if you do that, what it will produce will just be the same as every other person's agents can be producing. And there really is no need for you anymore. The company will just get rid of you. You need to be that valuable human in the loop that is able to really, define some architecture that you want the agents to follow, or to, pick out the piece that is so creative or so innovative that you drive your agent in a different direction to other people's stuff. And that, I think it's a key message, because it is very easy to just say, go ahead and do it all for me, and I'll just lie here and have a little break. But that's not going to work for you or your company. Human in the loop is important.
I think that's a really, really good point. Yeah, totally agree on that one. And then the last thing that I have on here is that agents kind of, I think a lot of agents will need to maintain context to move towards that goal, such as like a thread of conversation. So I've put this in to differentiate between a couple of ways you can go about doing connected agents or multi-agent architectures that I've seen. And if we get time, I'll show you AI Foundry and how at the moment it works in a multi-agent architecture. And it's brilliant for a lot of use cases. I think it's actually really, really good because it's very simple. But there are some use cases that I don't think it will actually really help with. I mentioned multi-agents there, and I think that's another really interesting one. Like, why do we need multi-agent architectures? So, really simple is good in IT. That's something I've learned over my time. Like, complexity is often makes things difficult to run, to manage, to maintain. So simple architectures tend to often outlive more complex architectures. And I think agents are going to be the same thing. And I think today we see a lot of people, before they think about the problem they decide that they need a multi-agent architecture. And I think a lot of this comes back down to the GPT or whatever your LLM of choice models were of the last couple of years. And over the time period, we've seen the GPT series, for example, move from the GPT-3 to 3.5 Turbo, where a lot of people first came across agent architectures. And those models, as good as they are for some problems, they often struggle to work out the best thing to do when they're overloaded with context. So context comes in many ways to agents, right? The obvious way is the system prompt that you start with inside of your chat with an LLM. But another thing that we see is MCP and tools. And especially with MCP, it's becoming so easy to get the idea of tools into an agent, and tools are the things that an agent can use to work with its outside world. I, for example, looked at my GitHub Copilot the other day and saw I probably had about 200 MCP tools on offer. They were all checked. So every time I'm issuing a prompt to my agent, I'm passing in a ton of context. Now, if you go back a year, you couldn't pass that much in without starting to overwhelm the agents. So it was natural to think that, well, I need to break this out into multiple agents to actually get a result. But I think now with models like 4.1 and 4.5 and Claude 3.7 and the reasoning models now, which can use tools, they're becoming a lot better at taking more and more context in. So I think, the first thing I would say is, especially if it's for within your own organizational walls or to model like a single process, step back and think, do I need multi-agents, or can I make this work with a single agent, first of all? Because it's going to be a lot simpler if you can.
Yeah, I think while you're on models, that's another important thing to point out. I often ask people, what's the best model? And of course, that's a trick question because different models have different capabilities. They have different knowledge that they've been trained on, and they work in different ways. Those reasoning models are great in that, you can see them reasoning things out and all of that, but you can also, to me, they look like my most over anxious friend who is taking the smallest thing that I've said and thinking, what did she mean by that?
It's
and
a trick question. It's a trick
20
question.
different things, and going awesome. Deep down into all of them, and I'm like, oh my god, I feel sorry for the agent in the same way as I feel sorry for my friend.
That's so funny. That's so funny. Oh, that's actually hilarious.
You mentioned Claude 3.7. However, I actually prefer Claude 3.5 when I'm doing for GitHub coding, because I feel like 3.7 is just so much more verbose. It is a little bit more of an overthinker.
Yes.
And I would like my code to be simple. Nice. I want my ideas to be simple. and I want to understand it,
Yeah.
and I want to build it as cleanly as possible. And
Yep.
Claude 3.5 seems to have a handle on that better than
Brilliant.
the newer model. So even like just picking the newer model is not necessarily a thing. So,
Absolutely. Yeah. I actually at Build as well with AI Foundry the other week, we announced we call it the model router. And
mm,
the idea of that is to try and address this problem, right? So sometimes, often up front, you can do your evaluation on the models to work out what the best one is. But I think as this world of agents moves forwards and these prompts maybe become more dynamic in nature, I think I saw an announcement that Semantic Kernel the other week is going to introduce something that allows it to be more contextually relevant when it chooses the MCP tools to put into the chat completions prompt. So you might end up in this scenario where at runtime you don't know is that going to be a really complex chat request or is it a simple one? So the idea of the model router is that it will actually look at the request as it comes in and it will try and balance to get you the best outcome with the cheapest or simplest model that it thinks can handle that request. So actually taking that decision and doing it at runtime rather than at design time. So some really interesting innovations coming in that space.
yeah, I need to look at that actually. The router really does look like an interesting component that will make things a lot easier. But yeah, I need to
Yes.
get my head around it.
Yeah, awesome, awesome. So let's say we decided we need a multi-agent architecture. Now, this is the state of play really with AI SDKs today, right? If you choose an AI SDK and a different team chooses a different AI SDK, then the chances are they're not going to be able to talk to each other. So semantic kernel might be able to talk to semantic kernel, but really most of these they're SDKs. They don't have an API as such that you expose to the outside world. You build them inside your application. So they're kind of locked in, like they're on these little desert islands where they don't really have a way to get out and talk to another agent that might be running somewhere. So that's really the idea of agent to agent. I'm flicking around these slides. I really should have ordered these better up front, but it's quite a good experience as to try and remember where I need to be.
Hmm.
So here's the idea of A to A in a nutshell, right? We've got this concept of agents. We know that we give them agency, we give them access to tools, but they may be inside different organizations. They may be inside the same organization, but across domain boundaries even. And maybe you're a Java domain, maybe you're a .NET domain. So you're not using the same SDK. Maybe you work on AWS, maybe you work on Azure, maybe your other teams work on Google. A lot of customers do have multi-cloud architectures. So the idea of A to A is about bringing this open standard to allow AI agents, assistants, to communicate and collaborate effectively. It's actually very simple when you look into it. There's not much to it, but it just provides a common language for agent interactions. It's not an SDK for building agents. I think that's really important to call out. It's not like you throw away your semantic kernel agent or your crew AI agent. That still stands. It's just like we put a little server on top of it, and that server can handle A to A requests that come in, and it can push out A to A responses. And that's the whole idea behind it. It's just coming up with an open standard to allow those agents to talk to each other and to discover each other as well. So very simple, but a very powerful idea because it's going to really enable these things to collaborate, which I think will lead the next kind of wave or generation of AI applications.
Hmm.
This is why I think it's important. There are a few other protocols out there to do this, but Google have got the backing of a lot of big companies. Microsoft are on board with this now as well. We're part of the working group. So, there's a few out there, like I say, but for me, if I had to put my money on one, I just look at this slide and it feels to me like this is probably the one that's going to get the traction today. So we do have an approach in AI Foundry today for building multiple agents, and we call them connected agents. And they're really good for a lot of problems. They allow us to break a complex agentic task up into little sub-agents that can all work together to try and fulfill that goal. But the way they work is that when the top-level agent decides to invoke the secondary agent, think of it less like an ongoing conversation with that agent. Instead, it treats it more like an MCP task or MCP tool, sorry, in that it creates a single message. It then calls the agent processes the message and returns a response. And that's the end of that interaction. So if the second agent couldn't fulfill the request, let's say it didn't have enough information, and it says back to the primary agent, like, hey, I need to know more, we're relying on the primary agent to resend the message, but with all of the information, including the extra information. So that works to a point, but if we have really complex scenarios, then what we're going to find is that we probably need the second and the first agents to maintain an ongoing thread of communication. So great for simple tasks and great, will suffice for a lot of architectures, but that's why we're looking at A2A today, is to see how we can get agents to maintain these long persistent threads and talk to each other. All right, so we're going to start looking at A2A now in more details. So if you're an agent, the first thing you need to do is you need to find the agents that you want to speak to. Now, with A2A, there's a few ways we can do this, but they all work on discovering this thing called an agent card. So an agent card is really, really straightforward. It's a blob of JSON that will tell you who the agent is, what it can do, how we authenticate with it, some example tasks and things like that allow us to start that communication. Now, I mentioned there's a few different ways we can find these. In the initial protocol, Google suggested that agent cards should be hosted on well-known endpoints. So they have this standard. In fact, I've got it in my agent over here. So what I'll do is I'm just going to open up a browser tab and I'll bring that over into here. And I'm going to go and find my agent. Let's take my hotel aggregator agent and we'll grab its agent card URL and we'll put that in and we'll pretty print that. So here's an example of a agent card. So there's a few obvious bits of information on here. So the first bit we'll call out is we've just got the name and the description, all pretty straightforward, and a version. We have some information around the capabilities. So in my case, my agent's going to support streaming, which is great. So if we send it a message, it can actually give us a little bit of information on its progress. I'm thinking, I'm talking to this agent, I'm doing this, I'm doing that. Hey, here you go. Here's the initial result. Agents can also have support push notifications. So this is really great, right? This is the case where maybe we ask an agent to do something, but that might take a long time. And we don't want to hang around. We can't leave a HTTP connection open for 5 days. And we don't want the user to have to keep their browser open for 5 days. So push notifications gives us a way that the agent can actually call us back when it's got a result. So think of it when you call up a airline and they say, hey, there's a big queue, but give us your number and we'll call you back later. It's a similar kind of concept. We have security schemes. That's really important, obviously. This all follows standard open API security schemes. So if you want to know what's available, it's all part of this base open API specification, which has existed for a long time. So you can see this agent here actually wants an API key, which is going to get sent to it in the header. We have input and output modes. So again, we don't know if it's a website, it could be another agent, it could be something that supports images, could be something that supports audio. So your agents might have different ways that they can be spoken to and they can speak back. So again, we can define that in here so we can negotiate with the calling agent what the best way is to actually work with this agent. And then we get into the skills. So this is where we define what this agent can do. So in my case, you can see I've got a hotel information skill. I can provide information about hotels that we can book in Hawaii. And then we give some examples. So the idea of all of this is that when we're creating or crafting that prompt for the agent that's going to talk to this agent, we will bring these things in as tools that are available to it. And we will give it the examples, the metadata. One of the things about anything to do with LLM is the more metadata and descriptive information we can give it, the better the outputs are. So this is where we really kind of tell that top level agent how to talk to this agent. I've got another skill down here as well. So we can also book hotels through this agent. All good. Again, some more examples. And then we have you'll see the push into the enterprise world. We've now got this concept of an authenticated card. So this might be a card where you have
Just thinking you have expensive tastes for your agent.
I've never been to Hawaii, actually. I don't know why I chose Hawaii when I made this. But yeah, I've never been there. My holidays are a lot cheaper than these ones, basically. And then we have authenticated cards. So this is maybe there's some sensitive information in an Asian card. So you want to hide that behind a auth barrier. So, again, this is the enterprise moving in. I think we'll see more of this kind of stuff as bigger companies want to start adopting this as a way to work. But that's a general idea behind an agent card, all pretty straightforward. So we can discover an agent. We can load our own prompt up now with information about this agent so we know when we can talk to it. And that then takes us on to the next part of the protocol, which is really like, how do we talk to these agents, right? And this is where the A to A protocol comes in. It's pretty straightforward at the end of the day. It's JSON RPC over HTTPS. And it's based off some very, very simple messages that we can pass backwards and forwards to our agent. So I've got a little slide that shows those, and then we'll jump into a demo where we can have a look at these actually happening in the background. So the first one is the most important one. This changed about 3 weeks ago, by the way. This used to be task/stream or something, but that was that whole set of breaking changes that they did. So we have a message/stream, which allows us to send the message to an agent, and we get events back. We'll look at those in a minute. The idea of this one is that this is where the agent can tell us, I'm thinking, I'm doing this, I'm doing that, and keep us up to date on what's going on. We have message send. So it's very similar to message stream, apart from this is going to allow us to just send the message to an agent and either wait for a final response, but not get any intermediate information back, or we can actually provide it a webhook with this call. So we can send, that will be the end straight away, and then it will call us back when it's done. Then we've got a couple of bits of information around canceling and resubscribing to tasks. You'll see interchange between tasks and messages in A to A. Again, this all happened when the protocol changed a few weeks ago. Everything was kind of centered on tasks up till then, and that's all changed. So I'm going to flick to a beautiful demo. So basically this, let's just clear the screen to kind of like hit the drama, is Google's little Python test host. So it's a little Python application. You can get it from, you see here, the A to A project. This thing has changed its repository multiple times in the past few weeks, but it seems to have settled on A to A project. And it's full of samples. You'll find samples for different agent SDKs. You'll find samples for Python, TypeScript, not so much .NET. I'm happy to learn Python. That's my goal for the year, basically, is to become a Python person.
It is the best language.
I was cursing at it so much the last few days. I used Copilot, GitHub Copilot extensively to try and understand why this stuff wasn't working. And I just about got there in the end.
I'm only joking when I say it's the best language, because one, in fact, I tell people who are learning to code is that people have different languages that they find easier. And so, when I found Python, I was just like, this makes so much sense. This is so easy. Whereas C++ was a foreign thing to me, and it was so difficult for me to learn. And of course they forced everyone to learn it back then as the primary language when I was in uni.
Oh wow. See, because I was doing the cog sci, so my primary language in uni was Lisp. Of all languages. Yeah, so
I was happy with Lisp. Lisp was fine.
Lisp was cool.
Yeah, Prolog I really liked as well.
I did Prolog as well. Yes, that's really taking me back now. Yeah, Prolog and Lisp, they were my languages. Yes. And then I started my career in... Sorry, Michelle, what were you saying then?
I was going to say, when your mind thinks in a certain way, there are certain languages that appeal to you and are easier to pick up. And so, nothing wrong with those C languages. But yeah, for me, Yes, for me, Python is the best language, but for you, I can understand how it might be difficult.
Yeah, yeah, I find it really weird. I started my career in Visual Basic 3, and we used to get teased by the Delphi programmers back in the day for not using like a proper language, is what they used to say. So I think, that's probably why I fell into C Sharp and Java, because that was the kind of suggestion was that you had to be using like squiggly parenthesis and semicolons to be a proper programmer back in the day. It's terrible, isn't it? Right? But that's unfortunately the way it was back in 1996. So, but here we are,
Well,
Python,
the
UV.
front end programmers still get it.
Yeah, yeah,
People are
totally.
often saying that, CSS and HTML are not proper languages,
Right,
which is
right.
just rude. Rude.
Oh, and you see the things you can do now without even any JavaScript inside of web applications. So they've come really far, right, with CSS and declarative languages. But
Yeah.
here we go. I'm UV running. I don't quite know what that means, but I'm pointing at my agent, and this is basically this little CLI tool here. If you download the samples, that's where it lives. Is inside the samples Python host CLI. So this is just shipped by Google. It's a little test CLI tool. And I'm going to point it at my agent. So the first thing it's going to do is it's going to go and find the agent card. And then after that, it's telling me it's starting a new task. What do you want to send to the agent? So pretty much everything I just showed you on the website a minute ago, the agent card, and let's have a chat to it. So start with a very simple hello. Now this takes a little bit of time. I do apologize. So I've been trying to create an A to A server that runs on Azure durable functions. I love durable functions. Any opportunity I get to bring them into something, I will do. And it struck me that a lot of calls to agents can take quite a long time. And one thing I've always been taught when I've built applications is that the longer you wait for something, the more likely it is that something's going to go wrong. So durable functions actually gave me a really nice way when I'm working with Azure AI Foundry agents to be able to not have to keep a connection open for a very, very long time that could easily go wrong. But it means that the code is a little bit more complicated in the background and things take a little bit more time to run. But a couple of things happened when I did this. See, this is a great little tool. The first thing is that the agent sent me this first little bit of information back where it's told me that it is I can't see everything on here, so I'm just going to quickly try and get the scroll bars up so we can see all the information. Live demos. Yeah, maybe it is all there. Let's zoom in again. Metadata goes through status message. I'm just looking for the bit. There it is, the state. So you see, this is a working message. Basically, we haven't finished. We're just going to start drip feeding you some information back. In this case, it's a status update. And the status update is basically some text. It's kind of split over two lines here and here. Status is literally a message, a text part which says thinking. Now, all messages in A to A consist of parts, and a part is just an array of things. Now, you can have text parts, you can have data parts, so you could send images back if you wanted to, and I think there's a couple of others in there as well. So in my case, I'm just sending a bit of text back saying that we're thinking. And then what happened after that is that the agent, after it had thought, it's now sent back another message. This one, though, the status is a status update, my bad. You'll see this little property here that says final true. In the first message, it said final false. So with A to A, when we're streaming messages, we stream, it's not the final message, it's not the final message, it's not the final message, until it is the final message. Doesn't mean it's the end of the conversation. It just means that it's the end of the agent's turn in the conversation. So A to A is this turn-based idea. It's your turn, then it's the agent's turn. Then it's your turn, then it's the agent's turn. So in this case, final true basically says the agent has spoken. And in this case, you can see that it's come back with a message to me. Hello, welcome to our Hawaii hotel booking service, blah, 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 blah. So now we've had that in first message, we've been asked a question back. And if we go and send another question, I like the sound of the Hilton. We're not sending any files. And we wait for our AI Foundry agent to go off again. We get the state of working. Live demos. This is far easier to show on a PowerPoint presentation, isn't it? Because you know that you're going to be not having to be waiting for demos. Great choice, blah, 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 blah. Now, the final thing that gets sent back by A to A, or actually, I think this is the host that goes and gets it, is a status of the overall task. So this is just one status update. It's a stream event. This is everything inside that task. Now, what you'll see if you go into the backend and have a look is that the history is filled with every single message that's gone on so far, and we can get an overall snapshot of where the task is up to. But this is the general idea in A to A. The only thing I haven't covered is this little bit here that says artifacts. So with agent to agent, the goal of an agent is to end up producing some artifacts. So they can happen at the very end of the conversation, or they can happen as we're going along. Doesn't really matter, but let's say you're generating images. Once you've finally got an image, that will go as an artifact in the task. If you're booking flights, maybe there's a confirmation message that will go as an artifact in the task. So that's how the agents convey back, like the results of the actual task at hand, is by using artifacts. My agents don't generate any artifacts. That was a bit that I was kind of lacking when I built them, unfortunately, but that's what's supposed to happen. The other important thing is this context ID. So every task you ask of an agent gets a task ID, and they're all unique. They're generated by the backend server. In the original protocol, they were generated by the client. They're now generated by the server. You can also provide a context ID. So this is really cool. It allows you to link together multiple tasks. So if you think about, let's say, I don't like the price of this today, but I think there might be a discount coming next week. Then I might ask the agent, like, hey, could you monitor the price for me? So what the agent might do in the background is start to spin off like cron jobs or like tasks that run every 24 hours. They're separate tasks to this particular one, but they can all be linked together by the context ID. So I can drive a user interface where I can show the user, like, hey, you tell me when you want to book. It's your turn now in that initial task, but the cron job tasks can be executing in the background. And I can bring all of that together to say, you know, the price is now this, the price is now this, the price is now this. That I don't know if it is the best way of doing it. I was asking on the Google threads about how to actually approach a use case like that. And it's what I mean when I say it's a brand new protocol. There's nothing in to talk about that. There's a lot of people have opinions that that should be a first-class citizen in A to A. Then some people have opinions saying, no, A to A shouldn't deal with that. And the advice I got was maybe using the context ID to bring it all together is the best approach. So under the hood, that's what is really going on. But we can bring that together into a user interface. So I think I will just pull up my A to A client. So this is a little client application that I use to try and demonstrate this. We'll zoom in on that as well. Get a new one of those up. And we'll say npm. Come on, terminal.
Want to take a quick survey?
Yeah, nice. npm run dev. Okay. 64373. That's definitely the one. So my travel agent, you'll see a little pop-up that's happened then. That was basically my travel agent on its card had Entra authentication enabled. So to talk to this agent, I basically had to sign into Entra, which I did earlier, hence why we didn't see it. But let's go to Hawaii. So we're going to pull up the little Chrome helper tabs here, and we'll have a little spy in. So you see in this case, I got my little hello, but what's happening in the background is we've sent the messages request off. So we've posted a message, and this is to the message stream endpoint. I'll probably zoom in on that as well, because that was a little bit small. Then we'll drop that down. And if all goes well, then we should start to see the messages coming back. So here's my agent, it's thinking. So let's go and have a look at the actual event stream. Let's see if we can spy in on that. So these are the server-sent events that are coming back. If you've ever used Open AI streaming, you'll be familiar with this. This is server-sent events, and it gives a way to drip feed information back. So let's say I want to go and have a look at the travel. Yes, so what hotels are in Hawaii? So we send a new message off to the agents. And again, we're going to start getting that drip feed information coming back from it. I think it's going to be this one. So it's thinking again. But in this particular case, because the travel agent doesn't know, it's of course going to go and talk to the remote agent. So you can see now we've got speaking to remote agents, and we can see that up here as well, speaking to remote agents. So that's now starting a second task between the actual host agent in this case and the remote agent. So I want to see if I can pull those up as well. So let me see. My URL looks like this might actually work. So if I go to have a look at the tasks of the hotel agent inside here. So let me see. Have I broken it or not? Oh, I've broken my demo. That's a shame. This worked yesterday. We could see those secondary tasks, and we could see I've got the primary conversation with the user, but I also have a secondary conversation between the agent and the hotelier, where they're talking about sharing the context, etc., etc. And really, that's the protocol at the end of the day. It's really quite simple, but it's the power it brings by being able to connect these disparate agents is what it's all about. Most examples you'll see will be the same kind of hotel booking scenario. For some reason, that seems to be the canonical example of multi-agent at the moment, is booking travel. I think it kind of makes sense because this is an environment where the travel agents often don't own the flight companies and they don't own the hotel companies. So the idea of them all communicating sort of makes a lot of sense. We talked about authentication. One thing we didn't talk about is this idea of secondary credentials. So coming from an API world, we often talk about least privilege. And we talk about, let's say you're a banking application. When the user signs in, you don't want to ask them upfront for permissions to send payments and do this and open accounts, because that's kind of dramatic. And probably all they want to do is just read their bank account details. Similar with A to A, we don't want to ask for the world up front, and we often don't know what the world is as well, because the agents can do so many different things. So A to A has got this concept of secondary credentials, and the idea is that they're sent, the request for them is sent in a message. Like you can see a little example here. Zoom in on that a little bit, where we send a message which says we need additional auth for this, and we send what's called a data part. And in this case, we're saying, look, I need to get some credentials to read your friends from facebook.com. What the spec doesn't really talk about is the best way to get these back to the agent. And one of the things in the specification suggests putting them into a message and sending a bearer token back as part of the payload, which I was laughing with George, our security friend, the other week around persisting bearer tokens inside databases and the security credentials and things like that. I think that's where we're going to see a lot of movement in the coming months, with Entra Agent ID and Auth0 talking about things like using client-initiated back-channel auth, which was a part of a spec that I'd never read before, which is all around sending back channel requests on things like SMS to users. So for me, I think, the protocol's pretty sound. It doesn't go into great details of how to use it. I like to say, we have a language, but I feel like the grammar's not quite there yet. Like I had a interesting ask, which was, well, when do I send an artifact? Does that have to be the last part of a conversation, or can I send it in the middle of a conversation? Questions like that, there's not any good advice on at the moment. And I think that will start to come over the next few months as well. I think the security, just like with MCP, it's all really new stuff. And I think we're still working through all of that. So tread carefully with that as well. I think when it comes to more complex behaviors, like I talked about that cron task earlier, that's not really inside the spec. And at the moment, there's different opinions on how to do that. So again, I'd like to think that we'll get more solid advice coming over the next few months around how to go about implementing behaviors like that. And it is really early protocol. Like we're literally talking 2, 3 weeks ago, there's a huge breaking change. So be careful if you're thinking about going to production with this kind of stuff. So yeah, with that, I think that's kind of everything I had today for you on agent to agent.
That's cool. So then I want to clarify, we're if you're in a big enterprise, you're an enterprise architect right now,
Mm,
you wouldn't be planning to use agent to agent right now, but you would be upskilling on it and you would be learning
right.
everything you can about it so you can be ready because you think it's going to move fast around that
I
readiness.
think so. I think so. I think it's one of those things where understand it, kind of maybe sample a little bit in some sort of test environment with what it feels like to actually use it. Um, but as it stands right now, there's not great enterprise support for this. So the little Google have got a to A server, a reference implementation, for example, but the tasks when I looked a couple of weeks ago were stored in memory in a dictionary. So if that A to A server crashed, then all of those tasks are gone. So it's things like that that I think we'll start to see more solid implementations on
Mm.
over the coming weeks. I'm hoping, for example, A to A Foundry at Build, we announced that we have what we call an A to A API head. So I really can't wait for this to drop. They said it was GA. I haven't seen it yet, but it should be coming really soon. And what that will allow you to do, this is really cool, is take an AI Foundry agent, but actually instead of talking to it using the current REST API, you will actually be able to talk to it using A to A. So they said at Build that we were going to be one of the first companies basically to implement an A to A turnkey production ready thing. I don't know if it will be production or preview. Sorry, put a disclaimer on that one. But that's kind of awesome because now you don't have to host anything. You could literally create an AI Foundry agent. You can use tools like Azure Functions, which are really cool how they're implemented, or MCP clients to access your tools. You can bring all the data in. You can store all of your conversations with AI Foundry in your own Cosmos databases, and you can now get a turnkey A to A API head. That's a really, really cool place to be for me.
Fantastic. Okay, so we are going to put a bunch of resources on the GitHub log so that
Mm-hmm.
you can follow up with this and stay in the loop as to where this is going and where you want to be moving forward. Graham and I are going to stick around for another 10 minutes to answer questions in chat. So if you haven't put your questions in chat already, go ahead and do that. I will actually, for this episode, because I know there's always a lot of questions when Graham is on, I will put the Q&A on the GitHub log as well. So
Awesome.
do not worry, you will be able to find the answers. Well, as we know them at this
we'll,
time.
we'll come up with good questions. We'll
Yeah.
find the answers together.
So it's an
Awesome.
ongoing journey that we're
Totally.
excited to be taking. So thanks for joining us. Tell
Thanks,
your friends,
Michelle.
and we'll see you all next
Thanks,
month.
everybody,
Thanks,
for
Graham.
listening in and look forward to the questions. Thanks for having me back, Michelle. Cheers.
All right, bye.
Bye.